Welcome back to Python scripting for GIS applications. This is a class at the University of Alaska Fairbanks, spring semester 2013. Another problem that you can solve this week for homework is a least cost problem. I'm going to create a path that minimizes the cost crossing some cost raster surfaces. So basically in the homework you'll have a script tool where the user will input an existing line feature class representing existing roads, and then the user will input polygon resources, which is a polygon feature class, and then any cost rasters. And then your script will add up all these cost rasters to get a total cost across any pixel. And then once we have a total cost raster, we'll come up with a cumulative cost as we go away from the road. And then once we have a cumulative cost raster, we can basically determine the optimal path to minimize costs going from the existing road to get to the polygon resource. Okay, when we start, we have a list of rasters, and these are basically just strings. And what we need to do is create a list of raster objects. So I'll make an empty list called cost rasters, and then we can loop through our string of rasters and create raster objects. So for string in this list of strings, we're going to append to this empty list, and we're going to create a raster object from each string. So now if we look at this list, it contains these raster objects. So next what we want to do is add the cost to build a bridge across any pixel that has a bridge cost value, plus the cost. Lakes are barriers, so there are no data wherever there's a lake. We want to add these two together. So the easy way to do that would be to create a new raster object. We'll call it total costs. And then once again, we could use the cell statistics tool. So cell statistics, and then our list of rasters. So cost rasters. And then what do we want? We want to add them together, so that would be add all the raster pixels. And then how do we handle no data? So we want, if it's no data, make the entire pixel no data. If lake cost is no data or bridge cost is no data for a pixel, make that pixel no data. Okay, so tool is not licensed. I forgot to check on the spatial analyst extension. Okay, so now we've got a raster representing the total cost across any pixel. So then the next step would be calculate the cumulative cost as you travel away from the existing road, taking into account the total cost to travel across any pixel. So that's a tool called the cost distance tool. So this will be the cumulative cost, the cost distance tool, and that requires an input source data. So that's our road feature class. And then an input cost raster. So that's our total costs. And then the maximum distance, which I'll just take the default. So I'll just put in a quote, quote. And then the last parameter is an output direction raster. So I'll just call this dir.tiff. So that will calculate the cumulative cost as you go across the entire surface. Starting at the road, the cost will be 0, and as you get further and further away from this existing road, the cost will get higher and higher and higher. Okay, I forgot to specify that we want the extent of this raster to be the extent of the entire area. So I say Arcpy environment extent, so make it the same extent as our total cost raster. So then we can run our cumulative cost, so that cost distance tool. Okay, so let's look at what we have now in Arc. Okay, so here's our existing road, a line feature class. And then here are the 3 resources that we want to get to. And then these are the lakes we cannot go across, and then the streams that have a bridge cost associated with them. And then we calculated the cumulative cost from the road. So that's this raster. So as we get further and further away from the road, the cumulative cost increases more and more and more. So what we want to do is now use this cumulative cost surface and these resources to figure out the best minimal path to get from the road to each resource. So we'll use the cost path tool, and that requires the input where we're going to get to our resources, and that would be our resources feature class, and then comma, and then our cost distance. So that's a cumulative cost raster going away from the road. And then our direction raster. So that was called dir.tiff, I believe. And then for every zone. So each polygon will be a different zone. And then we execute this cost path. So the resulting raster is the minimum cost to go from the existing road to each resource, given that we can't cross any lake and it costs you more money to build a bridge to get across any stream. So then the last step would be to convert this to a polygon. So that would just be Arcpy.raster to polyline. So we're going to take our minimum cost raster and convert that to some output feature class. So I already have a variable for that name. So that creates a shapefile, and then we could symbolize that shapefile using our symbology for line. So then we have candidate roads to get to the resource from the existing road, and we could do things like calculate the length of each of these candidate roads. So how long will it be to build a road from this existing road to get to that resource, as an example.